All right, let's get right into it. We hear it all the time, right? Blockchain is the future. But if that's true, why is a simple credit card swipe like thousands of times faster? Today, we're going to unpack blockchain's biggest hurdle, scalability.
Yeah, it's a really interesting paradox, isn't it? You've got this technology that promises to change everything, and yet when you actually look under the hood, most public blockchains are just, well, they're slow. Super slow compared to the systems we use every single day.
And when you look at the numbers, it really hits home. Okay, so Bitcoin, it handles maybe 7 transactions per second. Ethereum does a little better, around 30. Now, hold on, because a network like Visa, we're talking tens of thousands in that same second. That gap, it's not just a small problem. It's the thing, the fundamental barrier that's really holding blockchain back from going mainstream.
So what's causing this bottleneck? And more importantly, how do we go about fixing it? Okay, so to solve this, developers are basically taking two big approaches. I want you to think of the blockchain like a super congested highway, right? Total gridlock. So your first option is to just upgrade the main road itself. Widen the lanes, repave the asphalt, make the whole thing bigger and better. Or your second option is to build new stuff on top of it. Think express tunnels, overpasses, bridges, all designed to handle that extra traffic without touching the original road. All right, let's dig into that first approach, improving the main road. We call these on-chain, or Layer 1 solutions. So one of the biggest upgrades here is the move from proof of work to proof of stake. Proof of work, that's what Bitcoin uses. It secures the network using external things, like ridiculously powerful computers and a massive amount of electricity. I mean, a huge amount. Proof of stake, though, is different. It secures the network using an internal resource, the crypto assets themselves. Basically, validators lock up or stake their own coins as collateral. And here's the kicker. If they try to mess with the system, they lose that stake, so they have real skin in the game. Another really powerful Layer 1 technique is called sharding. And this idea actually comes from the world of big databases. So instead of making every single computer on the network process every single transaction, which is super inefficient, sharding splits the whole workload up into smaller, manageable chunks called shards. This means the network can process a whole bunch of transactions in parallel at the same time. And as you can imagine, that dramatically boosts its capacity. And Ethereum's founder, Vitalik Buterin, has a great way of putting it. He says proof of stake is basically a kind of virtual mining. You get the exact same security effects as proof of work, but you do it all without that insane electricity bill. Pretty clever, right? Okay, so that's upgrading the main road. But what if that's not enough? Well, what about building those faster routes on top of it? And that brings us to the other approach, off-chain or Layer 2 solutions. A perfect example of this is a payment channel. You've probably heard of Bitcoin's Lightning Network. Honestly, the best way to think about this is like a bar tab. So imagine you and a friend open a tab by locking some funds on the main blockchain. Then, for the rest of the night, you can make all these tiny, instant transactions between just the two of you, totally off-chain. At the end of the night, you close the tab, and only the final balance, who owes what, gets recorded back on the main blockchain. It's just incredibly efficient, especially for lots of small payments. Now, Plasma takes this idea and really cranks it up a notch. It's a framework that lets you create a whole tree of smaller child chains that are all attached to the main blockchain. And these little child chains can handle their own business, their own transactions, their own smart contracts, and they just check in with the main chain every now and then to report their status. You can see how this would just massively reduce the workload on the main network, letting it scale way, way more effectively. Okay, so this all sounds great. We get all this extra speed, but it begs the question, right? Are we sacrificing security to get there? Well, not necessarily, because the security is actually baked right into the design of these systems. Think about it. In proof of stake, those validators have their own money on the line, so they're incentivized to play fair. With payment channels, the main blockchain, the super secure base layer, always has the final word on the settlement. And with stuff like Plasma, there are these built-in fraud proofs that act like an escape hatch, so users can always get their funds safely back to the main chain if anything sketchy happens. So, what does this all mean for the future? Well, the big takeaway here is that it's probably not about one single solution winning out. Instead, the future of blockchain is looking very multi-layered. You'll have the core chain, the Layer 1, providing that rock-solid security, and then all these other layers built on top that give us the speed and efficiency we need for everyday applications. So I really hope that helps demystify the pretty complex world of blockchain scaling. If you found this explainer useful, hey, a like and subscribe would be awesome. It really helps us out. Thanks so much for tuning in.